Welcome to Differential Equations with Laplace Transforms. So I have 3 bullet points here, and we're going to start off with what is a differential equation. I know you've seen many equations prior to this class, so you know what an equation is, but specifically, what is a differential equation? Secondly, we're going to talk about, and this should be why, not what. Why are differential equations important to you specifically in your area of study? And finally, I'm going to list some examples, but I'm specifically going to go through one example, a very simple example, but I think it's important to see the global perspective of differential equations and the power of it. Sometimes we lose sight of all the details in solving differential equations, and the math is really not hard. It's just trigonometry and calculus, which you've seen before. But again, the big picture, because we're going to have a lot of meticulous details in this class, and the problems will be tedious. But again, why are we solving these differential equations? Okay, so what is a differential equation? So let me just move this up here. So differential equations, so I'll just write definition here. So, and I'll go ahead and abbreviate it. A differential equation is obviously an equation, okay, that involves two main things. It involves an unknown function. So maybe put that in green. So an unknown function. And secondly, its derivatives. Right? It might have one derivative, two derivatives, depending on the equation. So a differential equation is an equation that involves an unknown function. So we can say an unknown function or unknown functions, and its derivatives. Now, derivatives is specifically, that's very important. Let me put that in maybe parentheses. So derivatives, meaning, so this one, the derivatives which specify how a quantity, right, changes, right? Keyword changes, derivative, slope, rate of change, with respect, of course, to, let's maybe write that down. So with, well, we can say WRT, with respect to an independent variable. So with an independent variable, right, usually denoted by X. In our applications, there'll be T for time, and it should be hopefully familiar to you in your former physics classes. Okay, so this is what a differential equation is. So let's just list a quick example. So a differential equation is basically an equation that has an unknown function and its derivatives. Okay, so let's just use y. So y prime plus y equals, okay, x plus 3. This is a differential equation because I have a derivative, right, the first derivative, and I have an unknown function, right? We don't know the function y. That's what the goal is. That's why it's called the unknown function. Now, we can also rewrite this differential equation. All right, we know from calculus that y prime really means the derivative of y with respect to x. So we can say dy dx, right, or ddx of y, plus our function y equals x plus 3. So that's another valid way of writing that. And we can also say dy dx, we can say write it as a function of, right, f for function, f prime of x plus f of x, right, because we know, right, y is a function of x, right, that's why I can replace that guy, right. So these are all valid ways to write a differential equation. Okay, so that's a differential equation, just one example. But what's a regular equation? Because there's a big difference. And there's, again, numerous equations I can write here. I'm just going to pick one, a trigonometric equation. So a regular equation, right? Or in other words, a non-differential equation. So let's say 2 cosine x plus sine 2x equals 0. So you might have seen this in a calculus class. To solve this equation, right? This is not a differential equation, right? There are no derivatives here. And I mean, we can use the double angle formula to solve this, this trigonometric equation. Well, let's go ahead and do it. It's actually not a bad problem. It's actually good review. So 2 cosine x plus sine 2x. Remember, the double angle formula is 2 sine x cosine x. This is actually a very good review. Well, we have sine and cosines. We can definitely factor out 2 cosine x. That's our greatest common factor. We'll be doing that a lot. There's my 2 cosine x, 2 cosine x. So 2 cosine x, and what's left over, and I have 1 plus sine x equals 0. So now I can use the zero factor property. Set these two guys equal to 0, right? So either 2 cosine x is 0 or 1 plus sine x equals 0. And if I solve for cosine x here, so it's pretty easy, cosine x is 0. And so the cosine of what angle, gives me 0. And well, that's definitely pi over 2 and 3 pi over 2. Right, those two angles, the cosine, right, the x-coordinate is 0. And then we have, of course, sine x equals -1, and then that happens at what angle is the sine -1? That is definitely at 3 pi over 2, right? It's a nice little review. There's my 3 pi over 2, and on the unit circle, that is definitely -1, right? My sine is -1. So we can, really discard this one because this is really just repeating this guy. But what I want you to see here is we have a non-differential equation. So we have a regular equation, and when we solve this equation, we obtain solutions. And these are my solutions, and these are numerical values. Okay, in a regular equation, right, we obtain it's a number, so, or a set of numbers in this case. Here we have 2 numbers, right? We can even add 2 and pi because sine and cosine are periodic functions. In a differential equation, when you solve that equation, your solution is actually a function as opposed to a numerical value. Okay, so that's the difference between a differential equation and a regular equation. Our solutions are going to be functions. They might be linear functions, which are very nice. They might be exponential functions, quadratic, a combination of functions. We'll definitely see trigonometric functions. So our solutions are going to be functions as opposed to numerical values. Okay, so the second bullet point, the question was, why are differential equations important to you? I probably should have mentioned this earlier, but I got carried away and very excited about doing the math. But differential equations definitely come up in a whole set of fields of study. They come up in economics, in physics, definitely engineering, and there are a lot of mainly engineers in this class, whether electrical, industrial, civil. You will be using differential equations. So it's a widely applicable area of study. And they're very important because they have so the most interesting natural phenomena involve change, and where change are derivatives, and equations with derivatives, as we've seen, are modeled by differential equations. These are our differential equation is a mathematical model. They relate changing quantities as opposed to static problems that you know, if you've maybe seen in a physics, a first year physics course involving with no calculus, for example. So that's why it's important, and I hope you enjoy this class. I encourage you to ask me questions. The third bullet was the example. I'm going to go ahead and do it in the next video because I can't exceed 15 minutes on a video, and it's not going to take, it might take 5 minutes, but it might not. So hopefully that was a good introduction, and hopefully got a good idea of what a differential equation is and the difference between a non-differential equation.